Okay, hi and to Dr. Rosita and Dr. Dayang. Today my group and I going to present about our ethylene production. So first of all, my group's name is Yai Productions Neighborhood. So my name is yuvaraj and kunalan.
My name is Nuraina Nabila.
My name is Ahmad.
Okay, so first I will start with my process description. The fat was given is natural gas and to produce ethylene. So our purity of ethylene is 99.9 and the production of ethylene is 6,000 ton per year. So this will be my fat and this will be my outlet. So next is process selection road. It will start with ASC unit followed by OCM, absorption column, striper, demetanizer and C2 splitter. This is my full BFD with the composition and the flow rate. Okay, so I will talk by part. So the first part is ASU. This will be my inlet and this will be my outlet. There is a two outlet from ASU. The purpose of ASU is to separate is a separation unit to separate oxygen and nitrogen and to get a high purity of oxygen. So the method of calculation is first I found the purity of oxygen and nitrogen from the journal and I use the ratio which is methane the ratio of methane to oxygen which is 3 to 1. Next is OCM. This is the reactive process. The conversion, the function of OCM is the conversion of natural gas to ethylene has been studied through oxidative coupling of methane using different plant layout, which are explained in the following section. The assumption made in this reactor is complete combustion with limiting oxygen. This is my inlet and this is my outlet. And this is inlet from ASU. And my pressure and temperature is this part. Next, this is my method of calculation. First, I found the conversion of CH4, followed by I use the stoichiometry and the yield. Then I use the atomic balance to get my values. And there are three chemical equations involved, which is this chemical equation. So next is absorption column.
Okay, so now we continue with the absorption column. These absorption units are used to separate CO2 from the process gas. Water have been used to dissolve CO2. MEA are being used to absorb CO2 with efficiency 90%. So this is inlet from the OCM and this is inlet with H2O and MEA. And it will separate CO2 and will continue to the stripper. So next we proceed to the stripper unit. This stripper unit is used to separate CO2 from water that have been used to absorb CO2. This calculation we have used material balance, normal material balance. So we proceed to the demetanizer.
Okay, this is my part demetanizer. For demetanizer, we have one inlet and two outlets. For the inlet, this is the outlet stream from the absorption column from before. So the first outlet stream consists of C2H4 and C2H6, while the other outlet stream consists of CH4 and 2 CO2 and H2O. The purpose of this demetanizer is to remove methane and other unwanted feed materials. So this is the method of how I calculate for demetanizer. First, for C2H4 and C2H6, I use TBP, while for the other four components, I use TDP. And this ABC is the Antoine's constants, which we can find from the internet. So this is the constant that I use to calculate the TBP and TDP, and then to get the further my calculation. Next is the C2 splitter. For C2 splitter, I have one inlet and two outlet. From the inlet is the outlet stream from the demetanizer, which consists of C2H4 and C2H6. And both of the outlet stream consist of C2H4 and C2H4 and C2H6, but their composition is slightly different. So the purpose of C2 splitter is to prevent thermal degradation of distilled materials. So the method of calculation for the maintenizer is just the same as the the method of calculation for C2 splitter is the same as the dematerializer. I use TBP and TDP. For the upper product stream, I use TBP because of its low volatility, while the lower product stream I use TDP because of its high volatility. And this is the same. I use ABC, which is the Antoine's constant.
Okay, now we proceed to the costing. So there is 4 inlet, 4 feed, natural gas, water liquid, MEA and magnesium oxide. So the total raw materials that we have used is 231 million. So the cost for the product that we sell total is per year 270 million. So the profit that we get is 38 million. This amount is for the minimum. So we proceed to the maximum. The raw material that we use is 308 million, and the production sale for the ethylene is 300 million. So we get the loss, which means we get 8 million loss.
Okay, so for the last part, we go to the recommendation. There is a certain recommendation to improve our production. So first, did not consider on the waste and impurities removed. The amount of the waste should be controlled and use a suitable method to process it for the safety of environment. Second, the cost of the ash should be considered. This should be included in the costing even if the amount might be small. For the third part is the cost of water should be considered, although it is considerably cheap and negligible. And the last recommendation from us is recycle concept should be applied to minimize the wastage and maximize production and profit. And for our conclusion part, so we finally had produced the ethylene with the purity of 99.9% and 6,000 ton per year. So that's all from our group, which is YAI group. Thank you.